Riveting by machine is faster than gun riveting. It is also more accurate because once the machine is correctly set up, every rivet is driven uniformly. Therefore, a pneumatic squeeze riveter is often used to rivet assemblies which can be moved to a machine. This bulkhead is a job for the pneumatic squeezer. Parts must always be held tightly together for riveting, so be sure that sufficient sheet metal fasteners are inserted. Now, the next thing to do is to refer to the blueprint for the size and type rivet to use. A round head rivet, alloy type AD, is specified. The 5 indicates the diameter of the rivet, 5/32 of an inch. The length of the rivet is determined by the diameter, 5/32, and the thickness of the parts to be joined, 0.064. Now, add the thickness of the two parts, 0.064 each. Then, add 1 1/2 times the diameter of the rivet. Thickness of both parts plus 1 1/2 rivet diameter equals 0.362. The nearest fraction of an inch is 3/8, which is the shank length required. This, then, is the rivet for the job. AN 430, round head. Alloy AD, marked with a dimple in the head to identify it. Diameter, 5/32. Shank length, 3/8 of an inch. To drive the rivets, select a rivet set from the rack. It is numbered to match the rivets for which it is used. Now, before doing any work on the machine itself, make sure that the air line is disconnected. With air disconnected, there's no danger of getting your fingers caught in the squeezer. Install the rivet set in the upper arm. Press it into the adapter. It's held in position by tightening the set screw. Now you can safely connect the air line again. Normally, do not change the bucking set. But for each new job, adjust the distance between the two sets. To do this, take 2 pieces of test material in which rivet holes have been drilled and place them on the lower set. Turn the hand crank. This raises the lower arm until the material is held firmly between the bucking and rivet sets. This gives you a first rough setup. Lift the upper arm to remove the scrap. To test the setup, insert a few rivets. Locate the rivet head in the rivet set and hold the material tightly together. If the parts aren't held firmly together, the rivets will swell between the parts, like this. Here's how they should look. Now, step on the foot pedal to operate the plunger. Let the material move with the plunger as it comes down. Just hold the material firmly and give with the machine. Keep the pedal down till the plunger rises. If you release it before that, the machine stops. The upset head formed by this operation should be 1 1/2 times a rivet diameter wide and 1/2 the diameter high. When the test upset heads are too high, turn the hand crank to raise the lower arm. Then make another test. Locate the rivet squarely in the cup of the rivet set. Hold the pieces tight together and level. Give with the machine. first trial upset heads in the top row are too high. The upset heads in the second row, formed after readjusting the distance between the sets, are okay, 1/2 diameter high. The machine is ready for the production run. With the parts held tightly by fasteners, insert the rivets. Locate the head of the rivet in the cup of the set. Hold the work level. Give with the plunger. Lower the work as you move to each new rivet. Don't drag the material against the rivet set. Keep your foot on the pedal till the plunger rises. These rivets have been well driven. Remember, when riveting on the stationary squeezer, be sure that the parts are held tightly together. Locate the rivet head in the cup of the set. Hold the job level and let the work move with the plunger. Don't drag the work against the rivet set as you move to the next rivet. There are many parts which can't easily be moved to the stationary squeezer. Therefore, a portable squeezer is often used on the production line. As in the large machine, when you press the trigger, air pressure forces the jaws together to form the upset head. As soon as the job is finished, always disconnect the air line. Now on this job for the portable squeezer, refer to the blueprint just as you did for the stationary squeezer. Use round head rivets, alloy AD, shank diameter 4/32. The thickness of the two parts plus 1 1/2 times a rivet diameter calls for a shank length of 1/4 inch. Lay aside a number of rivets and then select a rivet set from the die rack. But this time use a flat rivet set. The use of a flat set depends on company procedure, and in this case it's been okayed. Insert the rivet set. You can safely put your fingers between the jaws because you disconnected the air line. Now with the rivet set installed, you can connect it again. Place 2 pieces of test material between the jaws and close them. If they don't touch the material, you need a longer set. Disconnect the air. Remove the first set and install one with a longer shank. Connect the air and check with the test material again. Now both sets touch the material. Next, adjust air pressure by turning the metering valve at the end of the squeezer. Hit the trigger to see that the squeezer is working. Then squeeze a trial rivet in the scrap. Just as with the parts for the stationary squeezer, be sure you hold them tight together. This first trial upset head is too high, so increase the air pressure by turning the metering valve. Squeeze another trial rivet in the scrap. The second trial upset head on the left is okay, half a diameter high. On the other side of the sheet, you can see what the flat rivet set has done to the round heads. That's why the decision to use a flat set on the job is up to company procedure. Now insert the rivets in the job. See to it that the parts are tight before you go ahead. Hold the squeezer firmly against the rivet head and at right angles to the material. Be sure the sets hit the rivet squarely. Using a portable squeezer is quite easy. But remember, be sure the rivet set is long enough and that you adjust the metering valve for air pressure to get a good upset head. Hold the squeezer at right angles to the material and have the sets hit the rivet squarely. When you set up the portable squeezer and use it correctly, you're doing a job that usually requires both a riveter and a bucker. And the same applies to the stationary squeezer. Both machines are high-speed production tools when controlled by a skilled operator.